we would multiply it by the interest. So 70 times 0.045, because we need to know what is the interest for 1 year. So when I multiply that, I get $3.15. So we don't add any money, we don't subtract any money. So then you're going to take the $3.15 and multiply it times 3, which gives me $9.45. So you're going to add that interest back to the $70. So you would have $79.45 in your bank account. Okay? Number 2. Leah wants to save money on a new computer. The computer costs $400, but if you buy it on Saturday, it's 30% off. And if you buy it before 9 a.m., you get an additional, this should say 10%. So what Miss Lavelle would do is I would take the $400 and I would multiply it times 0.70, because that is the percent that I am going to pay of that item. And when I multiply it, I get $280. So then I would take that $280 and I would multiply it again by 0.90, because if it's 10% off, I'm paying 90% of that item. And that would give me $252 is what I would pay for that item. And then the last one, Michael wants to buy a basket of mangoes on sale for $4 before tax. The sales tax is 12%. So that is a percent of increase. So you would multiply the 4 times 1.12, and I believe that's 48 cents, if I'm right. Let me stand up real quick. Hold on. So I can get the lights to come on. So 4 times 1.12, yep, is 48 cents. So we would pay $4.48 for those mangoes. Okay? Any questions on that? Nope. All right. Oh, let's see. Xander, LOI did it in the exact way you did it. Awesome. Great minds think alike. All right, so we are on page 359, and we are going to describe and analyze cross sections of prisms and pyramids. And the objective today is to describe and analyze the cross sections of pyramids and prisms of all types with or without a diagram. So Brittany bought a candle in the shape of a square pyramid. So that's what the candle is here. It's not very clear, but that is a candle. She wants to know what the inside She wants to know what the inside of the candle looks like. She wonders what figures would be formed if she slices the candle. How could Brittany slice the candle to make a figure with a square face and a triangular face? So if I wanted a square face, what would I need to do?
Cut it horizontally?
Yeah, cut it horizontally, right? So we would need to cut it this way. And I can't spell. H-O-R-I-Z-O-N-T-A-L. Horizontal. Yep. All right, and if I want a triangle, See if I can get it to, there we go. What would I need to do? What kind of cut?
Vertically.
Yeah, we need to do it vertically, right? And I would need to go from the vertex. So it means I would need to go from here, and then I would have to cut it straight down the middle. So vertical. From the vertex. A vertical cut from the vertex. All right, so the turn and talk says, how can you move the slice of the candle to get a smaller or larger square face? So what would I need to do?
Move the cup higher or lower.
Yeah, so if I want it to be almost identical to the base, then I would need to cut lower, right? If I wanted it to be smaller, then I would need to cut it higher. So the answer would be make a, and it would still be horizontal. So make a horizontal cut, higher or lower. Depends on what you want. Large square or small square. All right, am I good? Or do I need to pause? Okay, so why are you not working? All right, I don't hear anything, so I think I can go on. All right, so I think that this lesson is very easy. So unlike the first horizontal and vertical cuts we did, they really didn't kind of show you pictures of what it looked like. But on this one, they do. So a cross section is the inside view produced by making a cut or a slice. In this lesson, only cuts made parallel or perpendicular to the base will be shown. So parallel means it's a horizontal and perpendicular means it's a vertical. Okay? So perpendicular is vertical and parallel would be horizontal. I don't know why they wanted to change the verbiage, but they did. All right, so we are looking at the rectangular prism. So it says, analyze the shipping box shown. What is the shape of the rectangular prism with two square faces? What are the figures formed when slicing the box from different directions? So the box is a prism. What polygon describes the two-dimensional base of the prism? So they're talking about the bottom and the top, right? So what figure, that was horrible, I didn't trace that right. What figure does that give me?
Wait, what shape is the bases, you mean?
Yep.
Squares?
Yep. So the bases are squares. Okay? And then, does it ask me about the faces? Yep. So the faces, though, are what? So that's this piece right here. Yep. Don't overthink it, guys. It's really that easy. All right? So now we're going to slice it, and we're going to slice it parallel. Or we're going to do it horizontal. So what figure does that give me? Yep, it has to be a square if the bottom is a square. Okay? All right, if we do it perpendicular, which is this cut, what do we get?
A rectangle?
Yeah. That's what I'm saying. Don't overthink it, guys. All right, so D is a pyramid. Consider the pyramid shown. Identify the two-dimensional base and the face. So what shape is my base?
A triangle.
Yes. And my face is also a what?
Are we gonna start going into like type of triangles again? I don't want to go into those.
I don't think so. I think our next unit is statistics and probability, which I really do not. I really do not like it, but whatever. All right.
Because when I was learning about those type of triangles, I wasn't really paying attention. So
Well,
I
thanks.
don't really know a lot about them.
All right. E, suppose you slice the pyramid shown parallel to its base. So we're cutting it this way. What shape am I going to get? So horizontal. What do we get?
Horizontal, you say?
Yeah, so if we're cutting it this way, what am I going to get?
Triangle.
Yep.
I think.
Yep, it's going to be something like that, right? So it'd be a triangle. All right, so if I do, sorry, these emails keep popping up. If I do a perpendicular slice through the vertex, so that means I'm starting here and I'm going all the way down. What am I going to have?
Triangle.
Yeah, I'm still going to have a triangle. Okay, so it says, suppose you slice the pyramid perpendicular to its base through one of the edges. What shape is the cross section? So now we're not going through here. We're going to go through like something like from here. That would be my cut. So what am I still going to have?
A triangle.
Yep, I'm still going to have a triangle.
So no matter what, for one of these pyramids, you always get a triangle.
For a triangular pyramid, yes. Okay, that's not always going to be so for certain prisms, and we're going to look at that right now. Okay, so if I have like this pyramid here, which is a hexagonal pyramid, and I don't cut it at the vertex, you can see it gives me a trapezoid, right?
Oh.
So that's why they're saying, does it come from the vertex or not? So some of them, it's important to know where are you slicing it, okay? Especially for this type of pyramid. All right, so let's start with A. So A is this one, which is a pentagon prism, right? So if I cut a parallel, which is this one, you can see that it's the same shape as the what? The base, right? And so this figure inside is still going to be a pentagon.
I was about to say trapezoid.
No, that's this one down here. All right. If we do a perpendicular cut, the bell ringer, oh, thank you. If we do a perpendicular cut, it's the same as what? If this one was the base, it definitely can't be the base, right? So it's got to be a face, and the face is a this is my face, and the perpendicular cut gives me a
Square or rectangle.
yep.
I think it's a rectangle.
Yeah, it is. Sorry, I was looking at an email that just came through. All right, so now we're looking at the hexagonal. So when we cut it parallel, we still get a hexagon, right? But when I slice it perpendicular, not through the vertex, that is when I get a trapezoid.
So the vertex is just a point, right?
Right, so the vertex would be the very, very top going straight down. That's what that would be.
So, like, let's say you have like a cylinder, and then the middle, is that the vertex? The middle of a circle? Or
Well,
like pyramid and stuff?
The middle would really be the diameter, wouldn't it? The center.
Yeah.
So cylinders are a little bit different. But any type of pyramid, you would have a vertex, because it's where all of those meet, right? That's the vertex.
All right.
Where even this, the vertex isn't in the middle. The vertex of these would be these points right here, where all of those pieces come together. Yep. All right, so what kind of figure would I get if I cut it through the vertex? That's kind of what the turn and talk is asking. So if I go through the vertex, I'm going to get a what?
A triangle.
Yeah, I should get a triangle.
Oh, I can see it. It's like half a triangle.
Yeah.
Which is what result is.
Yeah, I should get a triangle. All right. So, check understanding. This one should be pretty easy. And then the on your own is real easy, guys. So it says a triangular prism is sliced parallel. Okay, so here's my triangle prism. Let's see if I can draw it. Not bad, huh? So there's my triangle prism, and I'm going to cut it parallel. So that means I'm going to cut it this way. Right? So this would be parallel. What kind of figure would I have? That one's easy to see, right? All right, what about number 2? What cross section is made when a hexagonal pyramid, like the one in task 2, is sliced perpendicular to its base through the vertex? So let's go up to that hexagonal pyramid, which is this one right here, right? We already talked about that. So if it comes through the vertex, Xander told me what it was going to be. Yep, it's going to be a triangle. All right, so think about the next one, the cornflake box. So if I do it parallel, which is here, what do I get?
A rectangle?
Yes, a rectangle. And then 4 says, compare the cross sections made from slicing the cereal box parallel to its base and slicing it perpendicular to the base. So if I do it this way, what do I get?
Squares.
But it's not a square prism. What kind of prism is this? Right? And then my other box would be somewhere back here. Right? So it's a rectangular prism. So can I get a square from a rectangle?
No.
Yeah. So if I cut it, it's going to cut like this face right here. So parallel we know is a rectangle. And then perpendicular is also what? Yeah, it's also a rectangle. So we basically get the same cross section. Just one of them is going to be larger, right? So the perpendicular one looks larger versus the parallel. So perpendicular, we'll say, is larger. Okay? All right, so the On Your Own is very short. It's only one page. And to me, it's very easy. So the ones on the bottom, all you got to do is identify the cut and what figure it is. And then the number 5, 6, and 7 is using this figure here. Okay? All right. If you need me, I am still here. I'm going to pause the video because I turned my fan on because I'm hot.